Hi guys, welcome to session 5. Now that we are familiar with the basic language concepts, let's move on to the object-oriented concepts. So the most important thing in Java is the concept of classes and objects. Uh, a class is basically a real-life entity representation of data and functions. So basically, a class encapsulates data and functions. In Java, the terminology is we call the data as members and the functions as methods. So an example of a class would be a car. So if you see here, the car class has the same name, the same file name as the class name, and it has these following data members: tires, engine, and color. A car will have more properties, but I'm just listing three of them here. So, and it would probably have the following functions: so start engine and move and stop and check whether fuel is empty or not. So a class is a generic concept, and if we want to use a class as a specific component, then we have to create an instance of that class, one specific instance of the class. And an instance of a class is known as an object. So here's how we can create an object of the class car. So we use the data type, which is of type car, and we give the name to an object, let's say BMW, and we use the new keyword and call the constructor method of a car. I'll tell you what the constructor is. So a constructor basically is a method in the class which has the same name as the class. So here we do not have any parameters in this constructor, so we call this as a parameterless constructor. Every class will by default have a parameterless constructor implicitly. We do not have to explicitly define it like this. Even if we do define it, it doesn't matter, but if we want to do something special, then we can define it like this, and we can write some statements here. Or we can also define a parameterized constructor where we can pass a particular parameter like this, and we can equate the color to that. So we can create another object of the same class, let us say Audi, and this time we can call the parameterized constructor by passing in the color black. So we are explicitly specifying that the object Audi is of color black. So if you see, both the objects have the same data type car, which means that they have the same data members and the same methods, but the values for these data members can be different. So if you see BMW, we are not specifying any color. So if we try to display the color of this car, it would just display a blank string. But whereas if we try to display the color of the car Audi, then it is going to display black. So now we need to understand what creating an object does. So by using the new operator, what we are doing is we are allocating a memory location to a data type of car. So if you're familiar with C++, it's similar to the malloc operation where we are allocating a memory location to a particular data type, which means that we can only store uh, data of type car in that location. So we cannot just assign some value to BMW, some integer value or something like that. So it has to be a data of type car. And when we create an object like this, what we are doing is we are we are creating a reference to that memory location. It's similar to the concept of pointers in C++ again. So where- when we equate this object to other objects, it's basically we are passing the reference of that object and not really creating another memory location. For example, if we had a something like this, if I have an object name with my car, and instead of using a new operator, if I just equate Audi to my car, so what this does is it's basically creating a reference, I mean passing the reference of Audi to my car. So if I try to display a property of my car, something like this, my car dot color. We know that the color of Audi is already, we have predefined it to black, so it will display black here when I run this. And let us say if I change the color of my car, if I want to change the color of my car to let's say blue, and if let me now try to print the color of Audi. Since my car and Audi have the same, is pointing to the same memory location, they both have the same reference. A change to my car actually has to reflect to Audi itself because it's the same location. So instead of displaying black, it is going to now display blue because we have changed the color by using a different object name but the same reference. Okay, now let me try to print the color of the car BMW. So since we have not initialized this variable for BMW, it should be null, so it is going to display null. So since since these variables have different values for different instances of the class, they are called as instance variables. So these variables that we have declared are called as instance variables, and they can be accessed by using the dot operator like this if they are public variables. So now there might be sometimes some variables of a class which are common to all the instances of the class. So we want like class level variables and not exactly uh, individual to an object. So we can we can declare certain those variables as static. When we use the keyword static, what we are saying is it is a class level entity. It could be a class level variable, data member, or it could even be a class level method. So let us say, for example, number of tires, number of tires, which is common, number of tires, which is a common thing for all the cars, whether it's a BMW or an Audi or anything. The number of tires is always 4. So we can initialize the variable at declaration itself, and if you see this Eclipse is showing this in italics. Eclipse shows all the static methods or variables in italics, so it indicates that it is static. And now if we want to access the number of tires variable, we cannot do something like this. We can use the object too, but the right way of accessing number of tires is by using the class car dot number of tires, something like this. So if you see, this is causing a syntax error because we are not assigning this to anything. So int ty is equal to, so whether we display ty or x, it's going to display 4. Because it's common to all the objects, we can use the object to access it, but we can also use the class level operator like this, class dot the name of the static variable. So let me try to print this. And I'll also print x. And, let me rename this to BMW X. Oh, sorry, Audi X. So it is displaying 4 in both the cases, whether we use the object or the class. Here's something interesting. Let us say I increment this Audi X. And now let me access the same variable by using the BMW car. And let me display that. Let us see what this displays. So if you see, I only incremented Audi of X. The, the reference of number of tires is now stored in the primitive data type Audi of X. So since this is a primitive data type, if I increase Audi of X, it doesn't affect any other, even though all of these are pointing to the same variable number of tires, it is not going to affect any of these other variables. But instead, if I did this, let us see what this displays. So all I'm doing is, instead of assigning it to some other variable, I'm just incrementing the variable number of tires, and then I'm displaying that for different objects that we have, and even at the class level. So if you see, it's displaying 5 all the way down, because what's happening here is, for we incremented the number of tires variable for one object. Since it's a class level variable, it reflects to all the objects, so that's why BMW X also has value of 5 now, and car, the class level instance, also has 5, even though here we have initialized it to be 4. So if we did the same thing for other instance variables, this will not be this will not be true. So if I remove the static keyword here, it is no longer a class level variable. So first of all, I cannot access this at all, so I will not display this. What would happen is, just for Audi, the number of tires will be 5, but for BMW it will still remain 4. So let's see if that is true. So it has to display 5 and 4. So there you go. So this is about classes, objects, and references, and static. Um, and yeah, one more thing, since we have introduced the concept of static, uh, we see here, for all the main methods we use the keyword static. The reason for that is, for the JVM to start a program with the main function, it doesn't have to instantiate an object to access the main method. If you declare something as static, all it means is you don't have to create an instance of that entity. You can just access it at a class level. So that's why we have to start off the main function with static, because for the JVM to directly access main without having to instantiate the test class. So that's it for this session. Thanks for watching.